A very good day to all of you. Welcome once again for the topic Intelligent Transport System Part 2. Before starting the lecture, I would like to thank our Principal Sir, Dr. K.B. Judal Sir, my Head of Department, Dr. Paresh Abaria Madam, and all my colleagues who motivated me for this lecture. Now the topic covered in this session will be e-ticketing, traffic safety management, national road safety policy, low emission vehicle technologies and what is the future outlook, biofuels, how we can achieve energy independence and a clear transportation system, geographic information system in transportation system, global positioning system in transportation system, and a detailed topic satellite based navigation systems in India. So let's start now. So what is e-ticketing? E-ticketing is commonly known as electronic ticket. It is a paperless electronic document used for ticketing passengers. Let me highlight it. Used for ticketing passengers, especially in the airline industry as well as railways. It is basically used by airlines, railways, and nowadays other modes of transportation have adopted that. Even entertainment industries are now opting for e-ticketing. The key details which are covered on e-ticket are ticket number, means the code of that particular airline or railway or entertainment seat number. It is serial number. It a checklist, carriage terminologies like conditions, fares and taxes, a bifurcation, restrictions, payment form from which office it is issued, baggage allowances, and because of this convenience there is a global adoption for this e-ticketing. Now, e-ticketing in Indian Railways. IRCTC, Indian Railway Catering and Tourism Corporation, developed an online system for rail ticket booking. We all must have been using that. The website is www.irctc.co.in. It is a cashless booking. More than 58% of train reservations are made via e-ticketing. Tickets are available via mobile and automatic ticket vending machines across 1000 plus locations. The environmental benefits of e-ticketing includes reduction of paper. It eliminates the need to travel to booking office and thus traveling time can be saved, which results in saving the pollution as commuting by vehicle reduces. Now what are the advantages of e-ticketing? First and the foremost thing it is cost effective. Cheaper for airlines and passengers both, even for railways and passengers. It is convenient. We can book ticket anywhere, anytime, any place 24/7. No paper to misplace. It is digitally saved. It is faster in processing, means speeds up in checking and reservation procedures. It is eco-friendly, saves paper, reduces traffic, and as a result pollution can be reduced. The disadvantages are system failure. Sometimes system fails. Risk of data loss due to system crashes. No physical souvenir, means ticket memorabilia. Some people have what you can say a habit of saving the ticket for memories. That we cannot do in this. You have to take print out of it. Fear of change. Some people still prefer traditional tickets over paper tickets. So in summary, e-ticketing is already a developed and much used concept, and the use of e-ticket will be increased in coming days. Now let's see for the next topic, traffic safety management in India. Now current context, India has one of the highest rates of road accidents globally. This is very alarming situation. Rapid urbanization and growing numbers of vehicles have made traffic safety a critical public health issue. All road users, drivers, pedestrians, cyclists, all are affected by it. What are the key components of road safety? First, roads and highway designs, traffic laws and enforcement, driver and pedestrian education should be there. In schools, mass awareness programs should be conducted so that since the beginning, since the inception, students who are now about to become adult and are eligible for getting license are already aware by traffic rules and its seriousness. Traffic rules and regulation system should be implemented properly. Road safety signages should be followed properly. Vehicle safety instructions should be followed, should be read, and the person who is using the vehicle should be well aware of these safety inspections. and post crash emergency services should be developed. The infrastructure is there, but it needs to be improved in case of post crash emergency services. Now, what are the collective responsibilities in road safety management? So first and the foremost thing is role of the government. The government should develop a stricter road safety policies. It should generate funds for awareness programs, enforcing traffic rules and regulations for public safety, and building a safer roads and highways. What is the role of general community like you and me? We have to follow rules and regulations strictly, and we have to participate in the awareness program organized timely by concerned authorities, so that we can be updated through rules and regulations or any modifications in rules and regulations. Particularly now, what is the role of education sector? So the role of education sectors comes that we should integrate road safety in school curriculum. We should conduct training programs through experts and provides effective driver education. What is role of media? Media should be responsible and spread awareness via print and electronic platforms. What are the role of health professionals? We should focus on improvement of trauma care facilities, and we should conduct workshops on accident response systems. What are the infrastructure improvement guidelines? Let's see that. First, we have to use government approved designs only, like use of signage and overbridges, etc. Because there is a uniformity, there is a rule in use of signages. Second is establishing road safety authorities at national and state level. We should adopt safe system based policies. We should regularly update and enforce IRC code of practice, mandatory signage as per IRC norms, continual road safety performance evaluation should be there. We should appoint independent safety consultants, a third party inspection should be there, and we should create and provide ratings of qualified safety auditors and contractors, so that the overall system can be improved and should be made transparent, which will overall reduce the number of accidents in our country. Let us see overall what are the key objectives of National Road Safety Policy. First and the foremost objective is promoting the road safety awareness. We have to raise public consciousness about road safety issues. We should establish a database, a centralized information system to track the accidents and safety matrices. A safer road infrastructure should be developed by integrating of intelligent transport systems. Vehicle safety standards from designing till maintenance should be there. Driver competence, strengthening driver licensing and training to improve the driver skills. Protection of vulnerable road users means we have to implement measures for pedestrians, cyclists and other vulnerable groups who are most vulnerable in case of accidents. We should enforce safety laws. We should take strict environmental enforcement of road safety laws. Emergency response. Quick medical attention facilities should be made available in case of accidents. We should encourage research and development in road safety, so that human resource development and research in road safety can get a boost, which will overall reduce accidents in the country. We should strengthen legal and institutional support, so that road safety culture can be promoted, because it is creating a huge economic loss to the country also. Now let us see low emission vehicle technologies and future outlooks. Transportation emission. Over 50% of greenhouse gases are coming from direct combustion of fuels. These emissions are rising due to global demand, especially in developing countries like ours. The main concerns are internal combustion engines. Either they are 2-stroke or 4-stroke, which use basic hydrocarbons as a fuel. So we have to opt for low pollution vehicle options like advanced ICEs like SI engines and CI engines, hybrid electrical vehicles, battery electric vehicles, and hydrogen fuel cells. Fuel cells, they make use of hydrogen. The motto is zero local emission. they only emit only water vapor from well to wheels, and that analysis is very crucial. It includes production, transport and delivery. Best environmental performance when hydrogen is from renewable sources like solar, wind and electrolysis. The European Union focuses on ultra low carbon technologies like alternative fuels like biofuels, LPG gas, CNG gas, biogas. LPG is liquefied petroleum gas, CNG is compressed natural gas. Electric vehicles are receiving boost these days, and hydrogen fuel cell vehicles are also making their way. Biofuels. Biofuels are one of the key ingredients towards energy independence and cleaner transport system. It will reduce the dependence on the fossil fuel, and the oil market which we see is very volatile. It is a cleaner alternative to gasoline and diesel. Now what are the types of biofuel? So the types of biofuels are bioethanol and biodiesel. Both can be blended or replaced petroleum fuels. Now from which ingredients biofuel production takes place? So first and foremost things are energy crops like corn, sorghum, barley, sugarcane, sugar beets, etc. Another is biological waste like agricultural, domestic, some industrial waste and even commercial waste. They can be degraded and biogas can be obtained. Other sources are like potato skins, rice, yard clippings and tree barks. Let us see what is bioethanol. Nowadays bioethanol is in daily uses. Government is blending bioethanol with our regular hydrocarbon fuels like petrol, so that the dependency on petrol is reduced and a cleaner lower greenhouse gases can be emitted. So alcohol fuel made from sugar or starch rich crops, it reduces gasoline consumption and emissions. Biomass based diesel fuels include biodiesel and renewable diesel derived from biomass materials, usable in existing diesel engines with no modifications required. Can be also used as heating fuels. Now what are the environmental benefits? Lower greenhouse gases and air pollutant emissions, cleaner burning than petroleum fuels. So overall, if the greenhouse gases are reduced, then it helps in curbing climate change, effects of the climate change rather. Now let us see fuel cells and fuel cell electric vehicles. What are fuel cells? They are galvanic voltaic cells which converts chemical energy into electrical energy. It operates via redox reaction without combustion. This point is to be noted, that it operates without combustion, and there is a continuous supply of fuel, say hydrogen. So fuel cell reaction is hydrogen plus oxygen which gives electricity and water. This is the formula. The process is very clean because the byproduct is only water. The fuel cell electric vehicles use hydrogen fuel cells to generate electricity for propulsion. Functionally they are similar to constant fuel or air supply. Zero local emissions means no carbon productions, only water vapor. They are very quiet in nature, efficient and very environment friendly. The advantages are high energy efficiency because hydrogen has high calorific value, rapid refueling compared to basic electric vehicles. They are having long driving range and potential for renewable hydrogen integration. There is a potential, research is going on. So this is the upcoming area. Now what is GIS? First of all, the urban transportation facilities. Now they are shifting their focus from creating a new infrastructure to maintaining the existing infrastructure. And more emphasis is being laid on use of public transport and sustainable urban planning than individual transportation system in big cities. It drives the development of intelligent transport system and smart cities. Now what is role of GIS? First of all, GIS is Geographic Information System. It is a central platform for integrating, storing and analyzing spatial data. It is widely adopted by transportation agencies and urban planners because They have high application in highway and transport management. Mapping of population by densities, land use and travel behavior can be done. Infrastructure impact analysis like topography, land cover can also be covered by it. Route optimization, most important. Network level analysis and decision support system can be developed with the help of GIS. The key functions of GIS are thematic mapping and charting, spatial data visualization and overlay of the data, statistical analysis of data and modeling of data if any prediction is to be made, multi-layer data access and its integration. Though these are the key functions, the challenges lie in availability of data and its quality. Multiple or repetitive data increases our work. We have to segregate data first. So data availability is priority and the quality of data. Hardware and software upgrades from time to time are required. Funding and technical expertise is required. Standardization and interoperability is also required. The main advantages are spatial analysis capacity. Visual and map based data representation systems are there, and it enables data driven decision making for efficient transportation planning. Now, what are applications of GIS in transportation planning? So let us see first three in planning, designing, traffic engineering and conjunction management. First of all, it helps agencies in planning infrastructure efficiently. The travel demand forecasting can be done with the help of GIS. It supports complex analysis for future transportation system, combines land use, environmental, greenhouse gases and energy data for comprehensive planning models. It enables data-driven sustainable transport planning. So from the planning phase only, if GIS is implemented, we can avoid or we can overcome so many problems which are coming in further stages. Designing. Engineers use GIS with CAD tools for enhanced design workflows, incorporates imaginary elevation and environmental data, links design files with financial systems for accurate cost estimation, supports efficient labor, material and project management, a core part of modern engineering informatics system. Traffic engineering and congestion management. GIS is very ideal. We all make use of Google Maps. It is very ideal for congestion mapping and monitoring. It builds on base maps used in long range transportation planning. We are able to get real-time data congestion tracking in various corridors. It provides regional and corridor level perspective of traffic analysis. Another is traveler information system. One of the earliest intelligent transport system applications, provide real-time traffic conditions and alternative travel options. We see alternative routes on our Google Maps, integrates data from sensors and automated systems, offers journey planning for public transport, car sharing, cycling, parking availability, and it is widely used by both locals as well as tourists. Safety management with GIS. GIS helps to analyze accident data along with traffic volumes, road features and bridge characteristics. It enhances visualization. Inventory of critical infrastructure like traffic signals, narrow bridges, rail crossings. It supports decision making in safety improvement and bridge maintenance. It enables access to key data like average daily traffic, classification and sufficiency rating. These all collaborate and amalgamate, which enhances safety. Hazardous material routing can be done with the help of GIS, like risk-aware routing by integrating road attributes, demographic, topographic and weather data, and it helps to assess accident consequences on population and environment. Environmental management. GIS helps to evaluate environmental impact of transportation projects, assist in smart growth planning by combining land use, housing and job density, and environmental factors. These all parameters help in planning by combining all these features. Construction management. It integrates with the project and financial management tools and centralized data like schedules, budgets and contracts, surveys in geotechnical data, environmental and engineering studies. It improves project tracking and efficiency by providing spatial access to all relevant informations. By integration of all this, construction management can be done on timely, and tracking at every stage of the project is made easy. Now what is GPS? GPS. Now let us see what is GPS in transportation system. The full form of GPS is Global Positioning System. It is a satellite based navigation system that provides location, velocity and time data to all the users. Let me highlight it. It provides location, velocity and time data to users anywhere on the earth. It operates through a network of satellites that transmit signals to GPS receivers for determining precise geographic positions. GPS reduces traffic delays, fuel waste and emissions by optimizing routes and vehicle movement. So if routes are optimized and vehicle movements become more smoother, then these problems can be eliminated. It helps to manage commercial fleets of vehicles, transit systems and emergency response. It also helps in maintenance of crews. So what is the key benefits? Like real-time tracking. We can locate vehicles instantly for better dispatch and scheduling. It helps in navigation support. If vehicles are enabled with GPS system, it helps drivers for efficient routing. It also helps in transit management. It improves on-time performance and passengers information system. Logistic optimization. It enables time-definite delivery, time-bound delivery and provides regular time-to-time alerts if there is a deviation in the routes. It is integrated with GIS for better response. GPS feeds into GIS to road map features, plan maintenance and enhance safety. Fleet management tools, monitor speeds, routes, idling and engine status from mobile devices or control centers. Means we can get the status of the vehicle, either they are moving, they are idle, they are standing or they are facing some accidents. We can easily get information from integration of GIS with GPS. So GPS application in intelligent transport system. So GPS in ITS offers high accuracy positioning and it is widely used in traffic engineering for improving of safety, efficiency and real-time data. The key applications include automatic vehicle location. It tracks the real position of the fleet of the vehicles using GPS. Each vehicle sends latitude and longitude data to central server. Helps monitor fleet's movements and ensure better control and scheduling. In automatic level location, onboard GPS receiver is used to estimate position based on known routes. General fleet operations. It sends the nearest vehicle to service points, saves time and fuel. Useful for commercial logistics and emergency services. It also provides wide area and global coverage, making it suitable for local, interstate and international operations. Dynamic route guidance is assist drivers with real-time navigation using traffic data and GPS. It is also known as dynamic navigation system. Now sensors which supports GPS based navigation are odometer, which is used to measure travel distance either on the wheel or transmission mounted. Another is magnetic compass. It detects vehicle heading. Direction can be known. Another is tilting sensor. Monitors pitch and roll angles of the vehicles. Gyroscope measures changes in the vehicle directions. Digital maps via GIS converts GPS coordinates into map locations, supports route navigation and compares actual versus planned route. So the summary can be by combining GPS with supporting sensors and GIS based maps. Intelligent transport system enables accurate navigation, route optimization and improved vehicle management across transportation systems. Major benefits of GPS are enhanced navigation, it improves safety and mobility, real-time monitoring can be done, better passenger information like precise location, enhanced travels experience for passengers, and efficient road surveying reduces time and cost in infrastructure planning and maintenance. Now what is navigation? We all use word navigate, But what actually is navigation? So navigation is the process of monitoring and controlling movement of an aircraft or vehicle from one location to another location. It involves the determining the position and direction known as reference points or patterns. Types of navigation are land navigation for vehicles and pedestrians, marine navigation for sea-based travels, aeronautic navigation for aircraft navigation, and space navigation for spacecraft movement. Land navigation and smart cities. Traditionally, maps and landmarks were used for land navigations. Now, modern navigation systems include GPS-based computer navigation. Real-time positioning tracking and digital road maps are examples of navigation system. Now, what is satellite navigation and what are ISRO initiatives? So, satellite-based positioning is key to urban mobility and smart city infrastructure. Its application is in civil aviation, transport and urban planning. India's strategic navigation initiatives by ISRO are Gagan, GPS-aided geo-augmented navigation. It is jointly developed by ISRO and Airport Authority of India, enhances accuracy of civil aviation. Another is IRNSS, Indian Regional Navigational Satellite System, indigenous satellite navigation system which provides positioning, navigation and timing services. It is commercial and strategic applications are there. Satellite based navigation systems in India, as we already discussed, Gagan, which is GPS aided geo augmented system, a satellite based augmented system developed jointly by ISRO and Airport Authority of India. It enhances accuracy and integrity of GPS signals for civil aviation and air traffic management in Indian spaces. Fully interoperable with other international satellite based navigation systems, signal in space and broadcast via G satellite 8 and G satellite 10 satellites. IRNS or NavIC, Indian Regional Navigation Satellite System, India's own regional satellite system. NavIC, navigation with Indian constellation. It covers India up to 1500 kilometers beyond borders, provides standard positioning services for open for all users and restricted services RS encrypted for authorized users. So here is standard service, standard positioning service SPS, which is open to all, and restricted service to authorized users. Accuracy is better than 20 meters in primary service area. Key applications are maritime navigation in Indian Ocean, commercial vehicle tracking mandatory, and planned integration into consumer smartphones. India becomes fourth nation with its own independent GPS system. So we are fourth nation who is having its own independent GPS system. Let us see basic features. Indian regional navigation systems, there are 7 satellites in it. 3 are geostationary satellite and 4 are geosynchronous satellites. The orbit altitude is 36,000 kilometers. The cost is 1,420 crores. It covers India up to 1500 kilometers beyond its borders. Extremely accurate. Atomic clocks in each satellites. GPS receivers will not work and need special receivers yet to be developed. It is open to all the users, as we saw. Accuracy is better than 20 meters. 4 satellites which are in geosynchronous orbits in pairs move in 2 inclined orbits, appear from ground to travel in figure of 8, assisted in accurate position and determination. 3 satellites are geostationary satellites. Orbits appear from the ground at fixed positions in the sky. So these are 4 satellites and these are 3 satellites. 3 geostationary satellites which are blue in color, and in pair of 2 which are geosynchronous satellites. So Indian space segment constitutes 8 satellites. We saw 3 satellites in geostationary orbit, 5 satellites inclined in geosynchronous orbit, 36,000 kilometers. Each satellite transmits SPS, standard positioning system, in L5 and S bands. Ground segment, ISRO Navigation Center. It is responsible for monitoring, maintenance and control of satellite constellation, which includes key components ISRO Navigation Center INC, IRNSS Spacecraft Control Facility, IRNSS Range and Integrity Monitoring Systems, IRNSS Network Timing Center, IRNSS CDMA ranging stations, laser ranging stations, IRNSS Data Communication Network. So your user segment supports single frequency receivers, which is L5 or S band, dual frequency receivers, which are L5 and S bands, and hybrid receivers, which are compatible with IRNSS plus other GNSS, like example GPS. This is up to this. Now we are closing the second part of intelligent transport system, and the topic here is concluded. Thank you all for your listening. Thank you.